today we'll discuss about the chi-square, and also actually biostatistical part is the chi-square. So there are different types of non-parametric test. One of the test is the non-parametric test is chi-square test. It is a non-parametric test. It is not only based on any assumption or distribution of any variables. It is very useful for research, and it is most commonly used when the data are given frequencies. It can be used with any data which can be reduced to proportions or percentages. These tests involved in the calculations of quantity is called chi-square, which is derived from the Greek letter is chi. So and pronounced to actually they compare the two binomial samples, even they are small, such as in like incidence of diabetes in like 20 obese and persons with 20 non-obese persons, to compare the frequency of two multi-nominal samples, such as for diabetes and non-diabetes groups of weighting like 40 to 50 and 50 to 60 and 60 to 70 and more than 70. Like this is one of the example to explain the chi-square. Tests of association. First of all, there are the three types of principles. So first one is tests of association. So the tests of association between the events of binomial and multinomial samples. Two events of often can be tested for their association, such as cancer and smoking, treatment outcomes of disease. So like vaccinations, immunity, nutrition and intelligence, like cholesterol and heart disease, and weight and diabetes, and blood pressure and heart disease, to find that they are independent to each other or depend on each other or associated. So each one is associated. Some like calculation chi-square values, there are three essential applying chi-square. There are a random qualitative data, and lowest not less than lowest frequency is not less than 5, and the steps of assumption of null hypothesis, and it prepare the contingency of like a table note down like observed frequency of our data. So determines the expected number like E, and by multiplying the CT by RT by GT, that means total data by row total by column total by column total into row total by grand total. So these are the row total and into grand row total and column total, row total into column total by grand total. So just means that we will expect that data will come. So find the difference between the observed and expected frequencies in each cell is O minus E. That means observed data by expected data. Calculate the chi-square values for such each cell with observed minus expected whole square by expected. Some of restrictions of applications of chi-square tests applications in the fold will not give a reliable result. So with 1 degree of freedom in the observed values of any cells like less than 5, such cases edge corrections can be applied substituting. That means of chi-square by observed minus expected minus of by whole square by expected. Even the edge correction the test may be misleading if any expected value is much below the 5. In such cases, edge correction can be not applied. So in table larger than the 2 into 2, that is contingency table, edge correction cannot be applied. The highest value of chi-square is chi-square obtained chance or worked out given in chi-square tables at the different degrees like degree of freedom, under the probabilities of such as 0.05, 0.01 and 0.001. If calculated values of chi-square, the samples is found to be higher than the expected value of tables, critical levels of significance, probabilities of 0.05, like null hypothesis means no difference between the two proportions, or the null hypothesis independence to characterize is rejected. If the calculated value is lower than the hypothesis, no difference between the a difference is accepted. So exercise is calculations, and the method is majorly will estimation of association and correlation. So we'll see the strength of association here, that how it will be probability of will easily we can detect the in chi-square. It is a non-parametric test and qualitative test, and more than less than 30 samples also we can estimate, and more than 30 also this thing we will see about the chi-square. That's it. Thank you.